Hi everyone, and welcome to 1.2. So I hope you got your notes in front of you. You're ready to go, and let's see how this goes. Remember, if you have questions, make sure you're posting them on the discussion board. I wasn't quite ready. I was on 1.3. I apologize. This is linear equations and rational equations. So we're going to learn how to solve these. All right, our objectives of the day, we're going to solve linear equations in one variable. And I know this very first problem is ridiculously easy. So it's going to get harder, I promise. So don't tune out on me. We're going to solve equations involving fractions. We're going to have my pen working here. Here we go. I'm going to solve rational equations with variables in the denominator. And this is where you guys usually don't like it. So it's okay. Don't freak out. We'll be fine. We're going to recognize different identities and conditionals when things work and don't work, if they always work or never work. And then we're going to do some story problems. All right, the first part, we're going to simplify an equation. You just have to remember your basics. You get rid of your parentheses and your grouping symbols. Number one, you get all the variables that you're solving for on one side. Everything else goes on the other side. You isolate the variables, so you divide by whatever's in front of it or factor it out, and then you check your answer. Okay, so let's go down here. Pause and try it. Okay, your first step, you should have subtracted 5. Whoops, subtracted 5, maybe. There we go. So then you have 4x is equal to 24. You should have divided by 4, so x is equal to 6. All right, next one. Here comes the fractions, and I am going to do it a little bit more difficult probably than you need, just so you recognize it when I put variables down there. So I'm going to say 4 is really 2 times 2. I'm going to say 14 is really 2 times 7, and 7 is just itself. Remember, to clear this, you just have to have a common denominator and then go away. So if I look here, what do I need to make them match? Now, the first one, the 2 times 2, well, it's missing this 7, so I have to multiply it by 7. But whatever I do to the denominator, I must do to the numerator. Okay, let's look at the 5 over 14. That's got a 2 and a 7. Well, this guy has 2 2's, and he's only got 1, so he needs another 2. So I'm going to multiply that 5 by 2. What does the 7 need? Let's look. I've got 1 7. These guys have 2 2's, so this guy needs 2 2's. Well, that's just multiplying by 4, so we're going to multiply by 4. Okay, I want you to pause and try all that. Okay, now come back. Let's see how you did. Now, I'm hoping you made a mistake. I know that's terrible, but I want you to learn from it. So when you look at this, I'm going to write it out. That's 7 times x minus 3. That's equal to, well, 5 times 2 we can do. 10, right? Minus 4 times x plus 5. I'm betting you did all of that right. I'm betting you took the 7 and you distributed it right. So you had the 7x minus 21. And you're going, Mrs. Carter, what are you doing here? This is where I think you probably made a mistake. Did you distribute your negative through? Do you have a negative 4x minus 20 is what I want to know. All right, let's combine these here. So now we got 7x minus 21 equals, this here would be negative 4x minus 10 when I combine these two. All right, I'm going to bring the 4x over this direction. So this guy cancels. I'm going to bring the 21 to the other side. Oops. So this guy cancels. So now I have 11x equals 11. So x equals 1. Did you do well? I know, tricky problems and they're first at the beginning. Not nice. Okay, try yours. Pause and see how you do with this variable. Okay, the same thing. I'm going to say 18 is really, well, we'll factor tree it out just for some of you. That's 2 times 9, that's 3 times 3. So 18 is really 2 times 3 times 3. So this 2x doesn't have these 2 3's, so I need 2 3's over here, or a 9 for my 5. Well, the 18 has the 2 and the 2 3's, but he doesn't have this little x here. So I got to add an x, or multiply by an x, I guess I should say that correctly. The 3x, well, we got the 3x. He's missing a 2 and a 3 to make him match, or 6. So let's see how we did. We've got 2 3's, a 2, and an x. 2 3's a 2 and an x. 2 3's a 2 and an x. They all match. That can go. So now you have 45 equals 17x minus 6. Add your 6 to the other side. So now 51, I should draw my line, equals 17x divided by 17. I'm out of room. X equals 3. Okay, this next one, if you worked ahead of me, you probably saw an error. This says y1 equals y2, but you get two y1s down here. This here was really supposed to be y2. So fix that on your notes for me. And what I'm really asking you to do is set them equal to each other. So I want you to set this equal to this and solve. So we have, would you like to pause now and try it? So now you have 1 over x plus 4 plus 1 over x minus 4. That equals 22 over x squared minus 16. Okay, now for your next step, I'm hoping you took and factored this. All right, let's make them equal now. Let's do green. What does x plus 4 need to match, everybody? Well, it looks like he needs an x minus 4. Don't forget the numerator. X minus 4 looks like he needs an x plus 4. Don't forget the numerator. 22, well, he's got everything. He doesn't need anything. Okay, denominator's now gone. So we have x minus 4 plus x plus 4 equals 22. All these 4's are going to cancel, giving us 2x equals 22. Divide by x, and you should have gotten 11. Hope you did well. Aren't these kind of fun? Gotta like things that go nice and smooth for us. All right, these are the weird ones. They have different solutions, no solutions, or all solutions, and they're just kind of a little different. Okay, true for at least one real number is called a conditional equation. So it has one or maybe two things that work for it. An equation that is true for all real numbers is called an identity, so it's always true. In other books, this would be called consistent dependent. Just in case you run into that sometime. Then an equation that is not true, it's never true, that's called inconsistent. So we have always true, never true, sometimes true. So let's go look at this here. I have 3x plus 2 equals 3x plus 6. We distribute this 3 through, and we get 3x plus 6 equals 3x plus 6. This is always true. This is an identity or consistent dependent. Inconsistent, well, let's distribute the 4. We got 4x minus 4. Combine this, minus 4 plus 3 is negative 1. There is no way 4x minus 7 can equal 4x minus 1. You could have been done right here. If you don't see it, subtract the 4x, and you get minus 7 equals negative 1. That is not true ever. So this is never true. This one is inconsistent. All right, pause and try yours. Okay, you should have distributed your 2 and had 2x plus 6 equals 2x plus 4 minus 2. Well, this becomes 2x plus 2 over here. There is no way that 2x plus 6 will ever equal 2x plus 2. 6 cannot equal 2. This is never true. Whoops, true. So this one is inconsistent. Okay, let's see what this guy is. So we have x plus 3. Those parentheses are doing nothing. There's nothing to distribute. So we can just put that minus 2 there, which is the same over here. X minus 2 plus 3. They were doing nothing. So we combine these guys and we get plus 1. We combine these guys and we also get plus 1. This is always true. They are identical. All right, so since this is always true, this is known as your identity or consistent dependent. Well done. All right, let's do this story problem. It's not a real story problem because they did all the work for you. But that's all right. Let's see what we got here. Person with a low sense of humor have high levels of depression. All right, and in response to a negative life event. So if they have a low sense of humor, so they don't think anything's funny, they get depressed easy if something bad happens, is what this is saying. This can be modeled by my formula. So what do I know? I know my formula. We're going to write it down here. Is depression is equal to 10 over 9x plus 53 over 9. Okay, in this form, okay, what does x represent? That's a good thing. It's the intensity of a negative life event. So this is intensity of, negative life event. D is the depression level. Not that I know what any of this means. If the low humor group averages a level of depression of 10, so this is probably what I don't know. So I'm going, if D, because it's a level of depression, equals 10, in response to a negative life event, what is the intensity of that event? Okay, so if D equals 10, what is X is what we're trying to find. So let's put this in here. 10 equals 10 over 9x plus, 53 over 9. Okay, if you didn't pause this and solve it yourself, do so now. When I look at this, I don't like fractions any more than you do some days. So I want to get a common denominator, which happens to be 9, because look, they all have these 9s. So all I have to do is multiply this guy by 9, and my denominators are gone. Way easier. So 90 equals 10x plus 53. Subtract your 53. So now we've got 10x equals 37. So if 10x equals 37, divide by 10, move down a little bit. So x is equal to 3.7. So it's a 3.7 intensity. I don't know if that's high or low. I wish there was somewhere we could find that out. Okay, I hope you did well. Good luck on your homework. Make sure you post any questions you have. Have a